Hello and welcome to Science News. This is a segment we like to call The More You Know.
And today we are going to be talking about the exciting topic of gel electrophoresis.
A Swedish biochemist, this exciting fella behind us, let me show you guys a little closer, is named Arne Tiselius. And he developed a method of molecular separation known as gel electrophoresis. Make sure to remember that one. We're going to be talking about it a lot today, you guys. His method used a U-shaped sink with an electrode on both ends, which resulted in a separation of molecules in a free solution. This bioanalytical tool has continued to adapt to modern technology rapidly. It is used for several medical interventions and biometrics. You see, gel electrophoresis is the speed of migration of molecules in a medium using electric fields submerged in liquid to measure the size and charge of molecules. This is most frequently used to separate molecules into separate components. Gel electrophoresis is a standard practice in the field of science, especially biology. Speaking of biology, I have two very exciting guests here today. I am very excited to introduce you guys to them. And now I welcome molecular biologist Dr. Thompson. She knows a lot more than I do because I'm a news reporter and all my stuff is scripted. So I'm gonna have her sit down and tell you what she really knows about gel electrophoresis. Thank you for coming. Dr. Thompson, tell me, how does the process of gel electrophoresis relate to a medical intervention?
Gel electrophoresis is a widely used technique in science laboratories to separate macromolecules such as DNA, RNA, and proteins. This is a technique where molecules are separated based on their size and electrical charges.
So Dr. McDermott, tell me, how is gel electrophoresis used in the biotechnology industry?
Scientists use this process in things such as forensics, crime scene DNA, and checking DNA sizes and base pairs, and matching DNA lengths to see if they connect, medications, treatments, and many more medical interventions and biometrics.
So Dr. Thompson is back with us, and my question for you is, how is understanding gel electrophoresis important for understanding medical interventions?
Electrophoresis can be used to separate antibodies and antibiotics from any impurities. The process also enables researchers to determine the concentration of the antibiotic, making dosages more accurate. It is also used in various crime scenes and other events that would need to compare DNA, and scientists can do this by running the DNA strand or marker in the gel to estimate the length of the unknown fragments. This contributes to overall understanding of medical intervention since it's a contributor to the process of making medicine and determining DNA fragments.
That's awesome stuff. So who's this behind you?
This is someone who might have died at a crime scene, and we need to get the DNA from the crime scene to determine who might have been a suspect or the person dead if it is an undetermined body. So that is why we would need to collect DNA and put it into the gel electrophoresis from a crime scene.
Makes sense to me. How is the process of gel electrophoresis performed?
Restriction enzymes cut down the DNA into multiple fragments. Those fragments are negatively charged, so when they are placed in the lanes in the gel, they run negatively towards the positive electrode. It is submerged into a salt solution, also known as electrolytes, and the DNA is normally stained with UV dye, so when you observe it later in a UV light, the lower ones are normally towards the bottom, and the higher base pairs are normally towards the top because the shorter base pairs run through the gel faster and more towards the bottom.